Here I am discussing previous year questions asked in KSEB AE exam paper in 2014. I am making this video in 4 parts. Each part contains 20 questions. To get all AE post exam questions asked in previous year KPSC and detailed solution of this question, please subscribe our channel. Let me go through the question. First question. Kelvin's double bridge is used for the measurement of. Options are low capacitance, high inductance, high resistance, low resistance. The answer is low resistance. Kelvin's double bridge is used for the measurement of low resistance. And high inductance measurement is done by Hayes bridge. Low capacitance measurement is done by Shearing bridge. And for high resistance measurement we use Megger and other methods like loss of charge method and direct deflection method. Next question. Megger is basically a. Options are moving iron instrument, moving coil instrument, hot wire instrument, electrolytic type instrument. The answer is moving coil instrument. Megger is used for high resistance measurement. Operation is based on these two coils, potential coil and current coil. They are moving and these coils are connected such that their corresponding torque act in opposite direction. Next question. A quadrant electrometers measure. Options are charge, capacitance, inductance and current. And the answer is charge or potential. The primary function of an electrometer is to measure an electrical potential or charge. The major type of 20th century quadrant electrometers are Dolizelak, Compton and Hoffman. Next question. TOD meter is used for to record. Options are energy, time and demand, energy, power and demand, power, demand and time, and none of the above. The answer is energy, time and demand. Time of day metering allows electrical rates to be changed during a day to record usage during peak high cost periods and off-peak lower cost periods. TOD meter means time of day meter, which is also called time of usage or seasonal time of day meter. Next question. In an induction machine, if the air gap is increased, options are efficiency will be improved, speed will reduce, power factor will be lowered, breakdown torque will be reduced. The answer is power factor will be lowered. If the air gap of an induction machine is increased, the permeability of the magnetic circuit, that is rotor to stator, will decrease. This decrease in permeability causes an increase in reluctance of magnetic path, which in turn increasing the magnetizing current, and this will cause a poor power factor at loads, and magnetic flux in air gap will decrease and leakage flux will increase. Next question. The all-day efficiency of a transformer depends on. Options are its copper loss, option B amount of load, option C duration of load, option D both B and C are correct. The answer is both B and C are correct. All-day efficiency of a transformer means output energy in kilowatt hour by input energy in kilowatt hour in one day. That is output energy in kilowatt hour by output energy in kilowatt hour plus losses in kilowatt hour in one day. So all-day efficiency can be calculated only based on load cycle. So it depends on amount of load and the duration of load. Also it depends the losses, but the appropriate answer here is D. Next question. A transformer has a negative voltage regulation when its power factor is. Options are 0, unity, leading and lagging. The answer is leading. The voltage regulation is equal to E2 minus V2 by E2. E2 is no load secondary voltage, V2 is equal to full load secondary voltage. From the vector diagram of equivalent circuit, we get an equation for percentage regulation, that is equal to percentage R into cos phi 2 plus or minus percentage X into sin phi 2. Percentage R means per unit resistance or per unit resistance drop, and percentage X is per unit reactance or per unit reactance drop. Here plus sign is for lagging power factor and minus is for leading power factor. If the resistance drop is completely compensated by reactance drop, zero voltage regulation takes place. It is possible at leading power factor loads. Next question. Instrument transformer used in alternating current circuit for extending the range of option A ammeter, B voltmeter, C wattmeter, D all the above. Instrument transformer used in alternating current circuit for extending the range of current, voltage and power. So the answer is all the above. And instrument transformer are used for the measurement of power, energy, power factor and frequency. Also it's used in protective relays for the protection of power system. Next question. An autotransformer has a transformation ratio 0.7, supplies a load of 2 kW. The power transferred conductively from primary to secondary is. Options are 0.6 kW, option B 1.4 kW, C 0.35 kW, D none of the above. In autotransformer, power is not only transferred by induction process but also by conduction process. If K is the transformation ratio, then power transferred by induction is equal to 1 minus K into input kVA. kVA by conduction is equal to K into input kVA. Power transferred conductively is equal to 0.7 into 2, that is equal to 1.4 kilowatt. Next question. The number of armature parallel path in a triplex lap-wound 12-pole DC generator. Options are 12, 24, 36 and 6. The answer is 36. In DC generator there are two winding, lap winding and wave winding. In case of lap winding, the number of parallel path is equal to number of poles. In case of wave winding, the number of parallel path is constant, which is equal to 2. For a triplex lap winding, it's 3 into number of poles, that is equal to 3 into 12, that is equal to 6. If it's a triplex wave winding, then it's 3 into 2, that's equal to 6. Next question. The full load copper loss of a transformer is 1200 watt. Its copper loss at 50% of load would be. The options are 300 watt, 600 watt, 1200 watt, 1600 watt. The answer is 300 watt. We know that copper loss is directly proportional to square of the load current. So, the copper loss at X fraction of load is equal to X square into full load copper loss. Here, it's asked 50% load. So, 0.5 square into 1200, it's equal to 300. Next question. A 400 kVA 200 Hz transformer is operated at 100 Hz. Its kVA. Options are 200 kVA, 400 kVA, 800 kVA, 2000 kVA. The answer is 200 kVA. Higher the designed frequency of transformer, lesser will be the specific weight of the transformer. So, specific weight of the transformer means weight of the transformer per kVA rating. So, kVA rating by frequency is constant, that is specific weight is constant, that is 400 kVA by 200 Hz, that's equal to 2. So, when it is operated at 100 Hz, its kVA rating is 2 into 100, 200 kVA. Next question. Overexcited synchronous generator runs at. Options are leading power factor, lagging power factor, unity power factor, none of the above. The answer is lagging power factor. At the time of overexcitation, machine delivers the reactive power and operate at lagging power factor. At the time of underexcitation, machine absorb the reactive power and operate at leading power factor. Next question. The voltage between adjacent coils in a crossover winding of a transformer should not be greater than. The options are 500 to 700 volt, 800 to 1000 volt, 1200 to 1500 volt, 200 to 400 volt. The answer is 800 to 1000 volt. Crossover windings are used for high voltage winding of the small transformer. The windings are divided into number of coils in order to reduce voltage between adjacent layers. The voltage between adjacent coils should not be more than 800 to 1000 volt. Next question. The percentage of silicon in transformer stamping is usually, options are 0.4 percentage, 1.4 percentage, 4 percentage, 14 percentage. The answer is 4 percentage. Small amount of silicon is added to steel. That is 0.3 to 4.5 percentage of silicon by weight is added to steel. When silicon is added, its hysteresis loss is reduces. Also, there is an increase in resistivity which in turn reduces the eddy current loss. In large machine, high permeability and high efficiency is desirable. So, 4.5% of silicon is used. In small machine, 0.3% of silicon is used because efficiency is not critical. By adding silicon, the material becomes brittle. So, we can't add large amount of silicon. Next question. The permeability is 0.999991. It is classified as option A paramagnetic, B diamagnetic, C ferromagnetic, D ferrite. The answer is diamagnetic. In diamagnetic material, Km is less than 0. Km means magnetic susceptibility and mu are equal to 1 plus Km. So, it is less than 1. So, the answer is diamagnetic. Next question. Hysteresis loss varies with frequency as. Options are F, F raised to 1.6, F square, F raised to 2.6. The answer is F, but there is a condition. The hysteresis loss is equal to eta into B max raised to n into F into V. Here, PB is the hysteresis loss, eta is the Siemens hysteresis coefficient depending on the material, B max is the maximum flux density, n is the Siemens exponent ranges from 1.5 to 2.5 depending on the material. For silicon steel, it is 1.6. F is the frequency of magnetic reversal per second and V is the volume of the core. If B max equal to V1 by F. If B max is constant, then hysteresis loss depends on frequency. If B max is not constant, then hysteresis loss is proportional to B max and frequency. So, it is hysteresis loss equal to A into V1 raised to 1.6 and F raised to minus 0.6. Next question. Usual value of flux density Bm for a power transformer using hot rolled silicon steel is. Options are 1.1 to 1.35 Weber per meter square. Option B 1.25 to 1.45 Weber per meter square. Option C 1.55 Weber per meter square. Option D 1.6 to 1.7 Weber per meter square. The answer is 1.25 to 1.45 Weber per meter square. In cold rolled silicon steel, value of flux density equal to 1.5 to 1.7 Tesla. Tesla means Weber per meter square. In hot rolled silicon steel, value of Bm equal to 1.25 to 1.45 Tesla. Next question. the ratio of height to width while designing window dimension of a transformer can be? Answer, the options are 1 to 2, B 2 to 4, C 4 to 6, D none of this. The answer is 2 to 4. Ratio of height to width of a window is 2 to 4. The next question, screwing of rotor slot in induction motor helps in. Options are improving heat transfer, reducing noise, suppressing undesirable harmonics, all the above. The answer is reducing noise. Skewing of rotor slot is done to prevent cogging. This happens when the rotor slots and stator slots are same in number or they are integral multiple of each other. Due to this, the opposite poles of stator and rotor come in front of each other and get locked. It causes very high noise. Thanks for watching.